All right, welcome to Wednesday. Hopefully you guys did well on your test. Um, by the time you watch this video, I should have it all graded and it's in the grade book. For those of you that did poorly, same as for the quiz, just email me, ask for a reteaching. The reteaching is going to be I'll basically have you watch the chapter review again type thing, and maybe give you a couple extra hints. All right. Yeah, no homework to grade. Here's where we stand on the calendar. So there's 5 weeks left of school. The last week is going to be semester finals. The week before, those 3 days, Monday, Wednesday, Friday, I'll devote those to a review, which basically means this is the rest of the work. Meaning we're not going to get to chapter 12 doing a whole bunch of stuff with quadratics. Well, I mean, good news, bad news. Bad news is we're not going to get to it. So you are missing out a little bit. The good news is that, Algebra 2 does a reteaching of this. I guess fortunately, I've covered enough that you'll be able to handle geometry. Geometry just basically has you factor and solve some quadratics, which you've already had. What we didn't get to was the quadratic formula, and geometry doesn't use quadratic formula. Algebra 2 does, but it reintroduces it to you. So what we will do for you guys before you take the PSAT next year is that in geometry we'll just cover chapter 12, just the highlights of chapter 12, so that you can take the PSAT next year and be good to go. All right, keep cheering down. Here's your homework. Okay, I'm not sure why I didn't assign you 1 through 20 all, why it's 2 through 20, but it's probably a mistake on my part, but you can do 2 through 20 all. All right, so this chapter deals with irrational numbers, and it starts off with rational numbers. All right, so recall for number sets, the first numbers that humankind came up with, caveman, cavewoman, they could count rocks, 1 rock, 2 rock, 3 rock. We call those the natural numbers. It took many, many, many centuries. And then eventually someone said, well, what about 1 minus 1, right? And that's obviously 0. So many civilizations came up with 0, but the Indians get credit for being one of the first civilizations to come up with 0. So if you add 0 to the natural numbers, we get the set that's called the whole numbers. The whole, I guess, meaning completed. These are all the numbers, right? No, because what's 1 minus 2? We get negative numbers, right? So if we have the positive numbers, they're opposites, and we add 0, we get to the set called integers, which you guys have been using all year long for the last 2 years, pre-algebra and algebra 1. Then also, there are numbers between integers. There's an infinite amount of numbers between 1 and 2. Okay, there's an infinite amount of numbers between 0 and 1. Well, here's 2 of them. We call these numbers the rational numbers. Okay, write this down, please. Rational numbers are numbers that can be expressed as a quotient. Big fancy words that basically means a fraction, but a specific fraction. The numbers must be integers. You can't have decimal numbers in your fraction. So 3 is an integer, 4 is an integer, that's a quotient, 3 over 4, that's a rational number. Rational numbers are numbers that can be expressed as a fraction, a ratio, and the ratio is listed, here we go, Algebra 1 words now, the ratio is listed as A over B, where A and B are both integers and B can't be 0. Why can't B be 0? Take a look at it. It's a fraction. You can't divide by 0. Your calculator melts down. All right. So, that's the definition of a rational number. And you're like, well, I was pretty good with it just calling it a fraction. We call those rational numbers. Turns out that many numbers that don't appear to be rational numbers are actually rational numbers. For instance, 5 doesn't look like a fraction, but we all know it can be written as 5 over 1, therefore 5 is a rational number. Classically, rational numbers come in 3 different flavors. Well, the first flavor is your plain old generic, we call that a proper fraction, right? Where the numerator, the top number, is smaller than the denominator. Just remember, for it to be a fraction or a rational number, both numbers must be integers. That means it can be positive, negative. The top one can be 0, but the bottom one can't be 0. The denominator can never be 0. All right, so flavor number one, proper fraction. Flavor number two, improper fraction, where the numerator is larger than the denominator. And then the last one, of course, is your mixed number. It's a mixture of an integer and a fraction. That literally means 5 plus 3/4. Okay, we call that a mixed numbers. We also read that as 5 and 3/4. Well, since this is Algebra 1, we got to talk about it in the negative sense. Remember negative fractions. You've heard this from me many times. Negative fractions can be written three different ways. There's your first way. The negative is in the middle. We can put the negative on the top. We can put the negative on the bottom. But if the fraction is negative, you cannot put the negative on both. That makes it positive. A negative divided by a negative is a positive. I'm not saying you can't have a negative on the top and bottom. I'm just saying that if the fraction is negative, you can't have a negative on the top and the bottom, right? All right, let's do these ones together. Hopefully it makes a bit more sense. So this technique is we don't get common denominators, we just do the cross products. 4 times 8, I'm doing the first one on the left there. 4 times 8 is 32. 7 times 3 is 21. Well, which one's bigger? 32, therefore it's that symbol. Easy, right? Hopefully I've just sold you on why you want to do this. Just be careful when they're negative, because remember, the larger the number, the smaller the value. But we still do cross products. 7 times 5 is 35. 4 times 9 is 36. And you're like, wait a minute, a negative times a negative is a positive. Yeah, but this is where you've got to remember that's not what we're really doing here. I'm not really multiplying negative 7 times negative 5. Okay? Which one is bigger? Well, negative 35 is bigger, so there is your symbol. For those of you that need to hear that again, play that again. Rewind, play it again. There's 4 examples that I did there. But for those of you that are ready, go ahead and do this one all by yourself. Pause the video, answer the next question on the Google Forms, and then play and see your answer. All right, let's see. 5 times 4 is 20. 8 times 3 is 24. 24 is bigger than 20, therefore it is a less than symbol. The second one, 9 times 3 is 27. 2 times 13 is 26. Negative 26 is bigger than negative 27, so it's less than. That's pretty a neat trick, okay? And you're like, why did you teach me that a long time ago? Well, we didn't really do this before. I didn't ask you to compare two fractions that often. But, I mean, I agree. It could have been taught to you. They just chose to wait to Algebra 1 to teach you this technique. This is called using the means and extremes to compare numbers. You're going to see this again in geometry, just in a geometry setting. All right, I said 3 things. Here comes number 3. The last one is, yeah, it's a little bit more challenging. All right. Remember, numbers are infinite. That means they never stop. Rational numbers are infinite. Between any two fractions, there is an infinite number of more fractions, right? That's kind of hard to understand. Between 0 and 10, there is an infinite number of numbers. Between 0 and 1, there's an infinite numbers. Now pick any two fractions between 0 and 1, 1/2 and 1/3. It turns out there's another infinite set of numbers that are different. That's crazy, all right? But that's true. All right, so how do we find these fractions? How do we find fractions between two fractions? That's what I'm going to show you. So here's the game. I'm going to give you two fractions, 3/4 and 5/6, and you are going to tell me what fraction is halfway between those two. Okay, so you're kind of like finding the middle. Well, the best technique, and I'm going to use nice, easy, friendly numbers to show you the example. So ignore those two fractions for right now. Let me show you with nice, friendly numbers. How about if I gave you 6 and 8 and ask you, what's in between 6 and 8? Well, we all know the number is 7, right? But how would you do that mathematically? Well, mathematically, you would take the two numbers, 6 and 8, you would add them, and divide by 2. 6 plus 8 is 14. 14 divided by 2 is 7. So it turns out that that is the technique that we will use for those two fractions. We'll simply add them and divide by 2. Okay? So add them and divide by 2. So let's see. We got to do 3/4 plus 5/6 and then divide by 2. Remember, dividing by 2 is the same as multiplying by 0.5, or in other words, a half. All right. 3/4 plus 5/6. Ugh. Now we actually really need to get common denominators. 4 and 6. Common denominator of 4 and 6 is 12. So let's see. The 3/4 multiplied top and bottom by 3. That would give me what? 9/12. 5/6 multiplied top and bottom by 2. That would give me 10/12. So let's see. 9 plus 10 is 19. Anything to cross reduce there? Unfortunately, no. So that's 19 over 24. Okay, that one wasn't too bad. It can be bad when it's really ugly common denominators. But it turns out that halfway between 3/4 and 5/6 is 19/24. So the techniques, you take the two fractions, add them together, take half, or multiply by half. Either divide by 2 or multiply by a half. All right. So 19/24 is between 3/4 and 5/6. Ready to do one together? All right. So the technique is not hard to understand, it's hard to do. All right. So what's halfway between 5/9 and 4/7? Okay. Well, The technique is you add the two together, multiply by a half. So let's add them together. Common denominators. Ugh. What's the common denominator? Somebody help me out here. McKinley, what's the common denominator? McKinley just said 63. Good job, 63. All right, so let's see. We got to multiply that first fraction by what? 7? 7 times 5 is 35. So 35 over 63. And the second one, we got to multiply by 9. 9 times 4 is 36. Hey, don't let me talk too fast. Pause the video. Listen to my voice again if you don't understand where I'm getting these numbers. But make sure you understand where I got those numbers. So the technique is we add the two numbers. You got to have common denominators. We just did. And then multiply by a half. 35 plus 36 is 71. Anything cross-reducing? Hopefully at some point something will cross-reduce. In this case, no. 2 times 63 is 126. So 71 over 126. You are not going to guess these, right? Look at that ugly number. 71 over 126 is halfway between 5/9 and 4/7. That's just, you're not going to guess these answers. You actually got to do this math. Okay, for those of you who need to see that again, play the last two over again. For everyone else, here are two numbers. Same technique when things are negative, right? Just do the same technique. Add the two and then multiply by a half. Go ahead and pause the video, get to an answer, and then come back for the answer. All right, let's see. We got to add the two together. Mr. C was nice to you. Common denominator is 50. So that first one is what? Going to be 8 or negative 8/50ths. Negative 8 plus negative 9 is negative 17. And still nothing cross reduces. So let's see what we got. Negative 17 over 100. I mean, there you go. Negative 17 over 100. Cool? All right, for those of you who did that good, that's great. For those of you that didn't, play that again. Listen to the explanation again. Make sure you understand it. As always, if you have any questions, send me an email. I'll be happy to help you. If not, I'll see you guys on a Freitag, or Friday as we say in the United States.